Hey guys, welcome back to General Chemistry. Today we're going to talk about the kinetic molecular theory. So the kinetic molecular theory is going to be the simplest model that we use to explain the behavior of gases. So kind of a disclaimer here, the kinetic molecular theory is somewhat of an oversimplification, but we've got to start somewhere. We've got to make an easy, straightforward model to use to understand how gases behave. And then as we get to more advanced chemistry, we can look at what reality looks like a little bit more. But the kinetic molecular theory gives us a good place to start, gives us a good kind of baseline understanding of how gases behave. So this theory, gas is defined as a collection of particles. So it could be molecules like oxygen, which is O2. It could just be atoms like argon, neon. Those are just gases by themselves. So it's a collection of particles, and those particles are going to be in constant motion. The attraction or really repulsion between the particles is going to be negligible. So if we have a collection of particles that are all sitting in the same jar, is there going to be some sort of attraction or is there going to be some sort of repulsion between those particles? Well, of course there is. But we're going to assume that that attraction or repulsion is so insignificantly small that we call it negligible, or we ignore it basically, right? So if those particles are next to each other, we say, well, they're just probably not interacting at all. There is a lot of empty space between our gas particles compared to the size of the particle. So thinking about the room that you're sitting in, you may have a gas particle that's in the top corner of your room, and you may not see another gas particle until you get to the opposite side of wall down at the floor. So if a gas particle was the size of a marble, that would be the distance between those gas particles. It's the distance of the walls of the room that you're sitting in. We, of course, know gas molecules are much, much smaller than that, but that'll give you just an indication of how much empty space is between these particles. This is one of the reasons when we talk about gases being compressible. This is the reason that we can compress them, because we can push those particles a little bit closer together without affecting really anything else. So just know there's a lot of empty space between the gas particles. So this first statement is probably the more important of the two here. So the average kinetic energy of a gas particle is directly proportional to its temperature in Kelvin. So what that means, kinetic energy. So kinetic energy is the energy of motion. So if I increase kinetic energy, that means things are going to move faster. If I decrease kinetic energy, that means things are going to move slower. So if I talk about the average kinetic energy and it being proportional to temperature, what that means is if I increase temperature, the kinetic energy is also going to increase. Those particles are going to move faster. And if I decrease the temperature, the kinetic energy is going to decrease. They're going to move slower. So that direct proportionality, we're going to talk more about this in the chapter, but that direct proportionality just means this. If one thing goes up, the other goes up. One thing goes down, the other goes down. So increased temperature, increased kinetic energy. The other important statement here is the idea that the temperature has to be in Kelvin. So this is going to be something that I say probably 100 more times in this chapter. But when we're dealing with temperature in this chapter, it has to be in Kelvin. And then the last bullet point on this slide is collisions of one particle to another are completely elastic. So what do we mean by elastic? It means they just simply run into each other and bounce the other way. There's no transfer of any energy. There's no moving a particle from side to side. They just simply come into contact with a certain velocity, and they leave with the same velocity that they came into the collision. As opposed to an elastic collision where it's a little bit stickier. There's going to be some sort of transfer of energy between the particles. So the velocity they came in with is not going to necessarily be the same that they leave with. So this is more like reality. They're a little stickier, but we're going to assume that it's elastic and that there's no transfer of energy. So that is just the kinetic molecular theory. That's the theory that or the framework that we use to think about and talk about gases. This is a theory that I'll refer back to as we get to each of the simple gas laws. I hope you guys found this helpful.